Assalamu alaikum. I'm Shireen Gul along with Sadaf Zahid, and we are presenting the paper Fire and Smoke Detection Without Sensors, Image Processing Based Approach. This is a Turkish paper presented in a Turkish university, Electrical and Electronic Engineering, Eastern Mediterranean University. Computer vision based fire detection has recently attracted a great deal of attention from the research community. In this paper, the authors propose and analyze a new approach for identifying fires in videos. In this approach, authors propose a combined algorithm for detecting the fire in videos based on the changes of the statistical features in the fire regions between different frames. Novel models for fire and smoke detection using image processing is provided. The model uses different color models for both fire and smoke. The extracted models can be used in complete fire smoke detection system which combines color information with motion analysis. Because of the quick advancement in computerized camera technology, also advancements in content based video handling, more vision based fire detection frameworks are presented. Vision based system by and large utilizes three trademark highlights of fire that are color, motion, and geometry. The color data is utilized as a pre handling step in the recognition of conceivable fire or smoke. We have some systems along with their authors and developers. Philip et al. Uses color prediction information and the temporal variation of small subset of images to recognize fire in video sequences. A manually segmented fire set is used to train a system that recognizes fire like color pixels. Next is Chan et al. He uses chromatic and dynamic features to extract real fire and smoke in video sequences. They employ a moving object detection algorithm in a pre-processing phase. The moving objects are filtered with fire and smoke filter to raise an alarm for possible fire in video. They used a generic fire and smoke model to construct the corresponding filter. Another one is Torian et al. He proposes a real-time algorithm for fire detection in video sequences. They combine motion and color clues with fire flickers analysis on wavelet domain to detect fire. They have used a mixture of 10 three-dimensional Gaussians and RGB color space to model a fire pixel using a training set. The recent one is proposed by the Clegg et al. He proposed a general model for fire colors. The author combined their model with simple moving object detection. The objects are identified by the background subtraction techniques. Later on, they have proposed a fuzzy logic enhanced approach which uses predominantly luminance information to replace the existing heuristic rules which are used in detection of fire pixels. So here the question arises, what is actually the color space? When color need to be used in digital media like cameras and laptops, colors need to be presented in numbers because digital media can only understand numbers. Therefore, color space is a set of rules that allow describing colors with numbers. YCBCR is another color space just like the RGB. Now, what is YCBCR? YCBCR is same like RGB, another color space, but bit different spaces are taken. Here, Y is a luma component of the color. Luma component is the brightness of the color. That means the light intensity of the color. The human eye is more sensitive to this component. CB and CR is the blue component and red component related to the chroma component. That means CB is a blue component related to the green component and CR is a red component related to the green component. These components are less sensitive to the human eyes. Since the Y component is more sensitive to the human eye, it needs to be more correct. And CB and CR is less sensitive to the human eye, therefore it needs not to be more accurate. Color models for fire and smoke. YCPCR color space is chosen intentionally in this paper because of its ability to separate the illumination information from chrominance more effectively than the other color spaces. The rules defined for RGB color space in order to detect possible fire pixel or smoke pixel can be transformed into YCPCR color space and analysis can be performed. But the rules fall short in coming up with a single quantitative measure which can indicate how likely a given pixel is a fire pixel. So the implicit fuzziness or uncertainties in the rules obtained from the repeated experiments are encoded in the fuzzy representation. This provides us a way to express the output decision in a linguistic terms. The single output decision quantity expressed as a number between 0 and 1 will then give the likelihood that a pixel is fire pixel or a smoke pixel. Fire detection. As we can see in the picture, for a fire pixel, it is more likely that the Y component is greater than CB, whereas the X and Y are the refers to the pixel's special location. This is because the luminance information which is related to the intensity is naturally expected to be dominant for a fire pixel. The greater the difference between X and Y, X and CB component of a pixel, the higher the likelihood that it is a fire pixel. This figure on the right side also hints that CB should be smaller than CR. Similarly, a higher discrimination between CB and CR means that corresponding pixel is more likely a fire pixel. So we can summarize overall relation by the given equation, that is y of x comma y is greater than or equal to CR of x comma y, which is also greater than or equal to CB of x comma y. Here on the right side, picture A shows us the actual RGB image, and figure B is the Y channel, C is the CB channel, and figure D is the CR channel of the original RGB image. The equation given here, y is equal to y upon Imx, CB is equal to CB upon Imx, CR is equal to CR upon Imx, normalizes all the samples to the interval of 0, 1, so that the differences are in the range of -1 to 1, which is used in the membership function definition. Given image, each channel is normalized with respect to the given formula, and here in this figure, where IMX is a maximum intensity value, is set defined by the combination of Y, CB, and CR channels.
So, when we talk about smoke detection, same as fire detection, here we will model smoke pixels. But the smoke pixels do not show chrominance characteristics like fire pixels. At the beginning, when the temperature of smoke is low, it is expected that the smoke will show color from the range of white bluish to white. So, towards the start of fire, the smoke's temperature increases and it gets color from the range of black grayish to black. As we saw in the image of fire detection, most of the smoke samples are of gray color. So the smoke pixels here are defined in the form of these equations. Here, as you can see in the equation, the TH is a global threshold ranging from 15 to 25. This equation shows that the smoke pixel should have similar intensities in the RGB color channels. And next, next, so this here is an image being shown. So this image shows the smoke pixel segmentation defined with the help of the previous equation. This figure is actually the RGB input image in smoke segmentation. So the first column defines RGB input image, and the second column shows the segmented smoke images used with the help of previous set of equations. Since the smoke information will be used for early fire detection system, the smoke sample should be detective where the smoke has low temperature. This is the case where the smoke samples have color ranging from the here we can see from the above figure that the output is noisy, but the motion property of the smoke can be used to remove such noisy parts. It can be easily observed from the first row of the figure. The sky is detected as smoke because it's a property of grayish color, but we embed the motion detection part. The sky will be removed because it's constant color over the same duration. So, with the help of this idea, the rule defined in this equation is used with HSV color spaces used, and its application with previous set of equation will be defined in the next figure. Next. So, this is RGB input image in smoke segmentation. First column in this image shows RGB input image, and the second column shows segmented smoke image using the previously written equations. Next. So it doesn't. We have compared our new fire pixel detection model with the existing one. It doesn't show robust characteristics like fire pixel because of the reason we need more discrimination figures from features from smoke detection, which is needed to be combined with the smoke color model. It smoothes the edges of the background when the smoke starts, which is out of the paper scope. So for the comparison purpose, two set of images are collected from internet. One set is composed of images uh, that consist of fire, and fire set consisted of 32 images. The image in fire set shows diversity in fire color and environmental illumination. The other set does not contain any fire, but it contains fire-like colored regions such as sun or other reddish objects. Two types of comparisons are carried out. One is for the evaluation of the correct fire detection rate, and the other is for the false alarm rate. So the following criterion is used for declaring the fire region. If the model achieves to detect at least 10 pixels of the fire region in the given image, so is it assumed that the correct detection where the image are in the size of 320 into 240 for the false alarm rate, the same detection criterion is used with the non-fire image set. So next. So as here we can see a table. This table shows actually makes us clear that the new method supported with the fuzzy logic and defined by YC BCR colored space outperforms the model developed in the color spaces, both in high detection rate and low false alarm rate. So the new method shows the better performance with respect to the techniques defined in a paper because it eliminates the colors which are similar to fire colors, but it is not a fire. The new technique doesn't require a color defined in CBCR color plane defined in fire pixel classification using fuzzy logic and statistical color model paper. So in this table, YCBCR color space outperforms other color spaces both in correct detection rate and false alarm rate. So this is due to the ability of YCB-CR color space to separate the luminance from the chrominance for model in fire detection in video sequence using statistical color model referenced in the references column, and the rule falls short in describing single quantitative measure which can indicate how likely a given pixel is a fire pixel. So as a result, it becomes very difficult to discriminate between the fire region and the fire like region. The implicit fuzziness and the uncertainties in the rules is encoded in the fuzzy representation. This provides a way to express the output decision in the linguistic terms. So, in the result, the most needed discrimination between the fire and the fire like region is enhanced. This is clearly reflected in this table that 44.5 false alarm rate, and the reduction of 5% compared to the method defined in fire pixel classification using physiologic and statistical color model. So next, so here we can see the image. This is actually the sequence that consists of the forest fire, which is obtained from internet obviously. The sequence is recorded from a view of a helicopter, and the camera is not static actually. It is really clear that the proposed model detect the fire effectively. Next. So let me conclude to the paper. We developed two models. One, actually, this paper developed two models. One for fire detection, the other for the smoke detection. For fire detection, the concept of fuzzy logic are used to replace the existing heuristic rules and make the classification more robust in effectively discriminating fire and fire-like colored objects. And this model actually achieves up to 99% correct fire detection rate with 4.5 false alarm rate. For smoke detection, a statistical analysis is carried out using the idea of the smoke that actually shows the grayish color with the different illumination. And the developed model can be used as a pre-processing stage for fire and smoke detection system, as in the detection using statistical color model in video sequence by Turgay Kalik and his fellows. And as a future work, the region based fire and smoke recognition will be studied. Thank you.